Hi! In this video, we'll provide you with an introduction to the features and capabilities of the LiquidCool Solutions Explorer system. The Explorer is a rugged modular server system that's designed to operate in virtually any environment. As you can see, the Explorer's components are housed in a set of stackable, shock-isolating rack cases. These rack cases do a great job of protecting the servers and other elements of the system. They also make it easy to transport, set up, and tear down. Using this modular design, it's easy to tailor the Explorer's heat exchange solution to the given application and environmental conditions. This particular Explorer system has been configured with both liquid-to-liquid and liquid-to-air heat exchange systems in order to demonstrate the two basic cooling options. Let's take a few minutes to go over what's contained in each of the rack cases. We'll start at the bottom with the server rack case. This case contains 8 LSS-230 liquid submerged servers. These are high-performance servers equipped with dual Intel Xeon E5-2600 version 3 CPUs. The servers are completely sealed systems, which protects the electronics inside from any harmful elements in the environment. The connectors and cables you see here are IP67 rated, which means they're waterproof. You can actually hose down an LSS server, or even immerse it in water, and it will operate just fine. The power connection is in the front of each of the servers. As you can see here, the power is distributed using a PDU mounted in the middle rack case. Also notice the retention bar, which holds the server snugly in place during transport and for mobile deployments. Moving to the rear of the system, you can see that each server is equipped with 3 RJ45 ports for 1 gigabit Ethernet connectivity and a single USB port. As on the front, these connections can be waterproof by using IP67 rated cables, such as the RJ45 cable shown here. The 2 fluid ports, which connect each server to the cooling distribution system, use quick connect fittings, which can be popped off and clicked back into position without loss of dielectric fluid. Finally, as in front, there is a rear retention bar to hold the servers in place. Now let's move to the middle rack case. The main feature here is the manifold system, which acts as a connection point for circulating dielectric fluid within the Explorer system. Servers are connected to the manifold via the 8 smaller hoses. The larger hoses connect the manifolds to the cooling distribution units, or CDUs, in the upper rack case. There are 2 other components in the middle rack case we need to cover. As shown earlier, a power distribution unit, or PDU, is mounted in the front and distributes power to the servers and to the CDUs. Finally, in this particular configuration, the middle rack case contains an additional CDU, which I'll cover a bit later in the video. Now let's move to the upper rack case. The main components here are a pair of redundant CDUs. These are LL800 liquid-to-liquid CDUs, each of which is capable of dissipating up to 8 kilowatts of heat, or the equivalent of 16 high-performance servers running at full load. The LL800 CDU provides extremely efficient heat exchange, achieving PDU values as low as 1.01, and is an ideal CDU to use when a supply of cooling water is available. In this redundant configuration, only one of the CDUs is operating at any time. If the primary CDU fails, the second CDU starts operating automatically with no loss of cooling. These CDUs are also equipped with an RJ45 port for remote monitoring via a web interface. Let's move back to the rear of the system to view the fluid connections at the rear of the CDUs. The large hoses circulate dielectric fluid to and from the red and blue manifolds in the middle rack case. The hose on the left circulates the cool fluid from the CDU, and the hose on the right returns warm fluid to the CDU. As with the dielectric fluid hoses, the blue cool water hose connects on the left, and the red warm water hose connects on the right. Just remember, red on the right. Finally, you'll notice a cable connecting the 2 CDUs. This is the communication cable used to activate the second CDU if the first one fails. There's one more important component in the upper rack case to cover. In the rear, we've mounted a 1 gigabit switch to handle the network connections. For this system, the network connections are used for remote server management via IPMI. So that's the Explorer system in a nutshell. Again, this is just one of several possible configurations. For example, for installations where no access to water is available, the LL800 CDUs would not be used. Instead, cooling would be provided using a liquid-to-air CDU connected directly to the manifold system. Also, the most challenging environments would require CDUs with more ruggedization features than the CDUs in this particular system. Thanks for watching.